All right, hey y'all, and happy Friday. Today we're going to be looking at our next set of exponent rules. You should have turned in your lesson 2 into the sub if you didn't turn it in last class. So please make sure that you get that turned into her. And now we're going to be starting on our lesson 3 and adding in a couple more of our exponent rules. So this next one that we're going to be starting with is our dividing or our quotient of powers rules. All right, so this one's pretty easy too, and it makes a lot of sense again whenever you break it into expanded form. Side note, you better be being uber nice to our sub. She should be like, whoa, these kids are so nice. I was actually concerned about why they're so nice. Like, are they robots? What's going on here? Okay. I hope that's making you laugh. While I'm probably I'm in a mountain right now playing in the snow, definitely not thinking about y'all. Just kidding. I absolutely am thinking about y'all right now. I'm like, what are they doing? Are they doing what they're supposed to be doing? Blah, blah, blah. Okay, anyways, let's do our notes. On a separate sheet of paper, again, you should be taking your own notes here. So write down x to the 5th over x to the 3rd. Again, pause the note video as you need to so you can write this stuff down. All right, so let's do a breakdown here. This is x times x times x times x. I don't know if I said that enough times. Over x times x times x. So this rule ends up making a lot of sense. What is x divided by x? Well, that's 1. X divided by x is 1. X divided by x is 1. And you'll see that we're left with x times x, which is just x to the 2nd power. Okay? Try the next one out. See what you get. Okay? This is x times x over x times x times x times x times x. 1, 2, 3, 4, 5, 6. Okay? And the same thing is going to happen. X divided by x is 1. X divided by x is 1. And now we're left with this 1 over x to the 4th power. Okay, so what is our rule? Can you see what the rule is? Well, look at this 5 and this 3, and we ended up with a 2. Here we had this 2 and this 6, and we ended up on the denominator with a 4. So the rule is we subtract their exponents. All right, now y'all can be good about this because well, okay, we'll talk more about it. So here's the official ruling down here. But what you'll see is if your exponent is heavy on the top, then you'll end up with something like this. Now, if your exponents are heavy on the bottom, it's kind of like you take it down and subtract it from the bottom, because we'll learn another rule where we're not allowed to have negative exponents, okay? So instead, just pause and look at these or write them out in expanded form and see what you end up with. So since I ended up with these here in the denominator, he's going to stay down here in the denominator. This was bottom heavy, whereas this first example was top heavy. All right, so write down this official quotient of powers rules and then meet me on the next slide. All right, so 10 to the 5th over 10 to the 7th. Well, actually, that's kind of nice. We can just plug that one into our calculator, but hopefully you'll see that this would be 1 over 10 to the 2nd power. Since these are bottom heavy, I would subtract these down to the bottom. And then what is 10 squared? Well, 10 times 10 is 100. This is 1 over 100. And we can just pop that into our calculator to double check. We had 10 raised to the 5th power over 10 raised to the 7th power, and you'll see we get 1 over 100. All right, looking at this one, okay, this is n to the 1st power, n to the 1st power. All right, so let's see. Remember, we handle normal numbers like we would normally. 15 divided by 5 is 3. And then n to the 1st over n to the 1st, well, that actually just cancels each other out. That's 1, and 3 times 1 is just 3. All right, number 3 here. These are getting a little weirder and weirder. Good news is you can actually plug these ones into your calculator, but let's see what's going to happen. 12 divided by 4 is 3. All right, and then if I applied my rule here, 10 to the, well, now I'm going to subtract these up because I'm top heavy. All right, so 10 to the 6th minus 3 would be 10 to the 3rd power, and that's going to be some big number. If you're unsure, just plug it in your calculator. 3 times 10 raised to the 3rd power, and we end up with 3,000. All right, I did want to show you how you could plug this into your calculator. I want to show you too, okay, so we use this caret key. We have a built-in squared key here, but if we want to raise something to anything else, you use the caret key and raise it to that power. So right now I just clicked raise to the 3rd power. All right, and so I just plug that in, and you'll see again we got 3,000. So you can always plug that entire equation into your calculators very carefully. Okay, and let's look over here. All right, again, this is to the first power. So I would subtract my exponents up to the top, but I still have to handle this 9 over 12 like a regular number. If you're unsure, 9 divided by 12, math, enter, enter to keep it as a fraction, and that simplifies to 3 over 4. So I have 3 over 4, and I'm going to subtract my y's up to the top because we're top heavy. So 4 minus 1, we get y to the third power. All right, again, if we want to see that in an expanded form, that's 9y over 12y. Well, we just saw that this reduced to 3 over 4, and then one of our y's is going to cancel out, which is where we get that y to the third power. Okay? Whew, these just keep getting better and better. All right, why don't you take a stab at some of these? I'm going to pause the note video, and I'm going to do 2 of these at a time. So try out number 5 and 6, give it a shot, see what you can do. All right, so here I am coming back on for number 5. All right, so first, again, handle your numbers like you normally would. We want to simplify that fraction, and that simplifies to a negative 1/4. All right, I wrote it up here in an expanded form, so we simplified our fraction. One of our a's is going to cancel out, so I don't have any a's in the denominator anymore, and one of my b's are going to cancel out, so I don't have any b's in the denominator anymore. So we can see this is going to simplify to a negative 1/4, a to the first, b to the second over c. All right, now there's 2 ways of writing this. As you can see, you know, mathematicians are kind of lazy whenever it comes to writing those ones. So it's kind of an assumed one up there. So you could write it this way or that way. Either of these two makes sense. I put the negative out here. You can put the negative exclusively on top. But it's negative a b to the second power over 4c. All right, so either of these 2 answers will do. High five yourself if you got that one right. I'm going to pause again and do number 6. All right, so coming back on again here for number 6. All right, negative 12 over negative 20 simplifies to a positive 3 over 5. We'll see one of our r's cancels out and one of our s's, so I'm just left with an r on top and an r on bottom. So 3r over 5s. Great job if you got that right. All right, go ahead and write down number 7 and 8. I'm going to pause the video and complete 7 and 8. You can resume after you're done to see if you did it right. All right, we had some fun problems here on 7 and 8. These are wild. All right, so you can see I wrote it out a couple different ways. There's so many ways to approach it, so you just have to figure out which way makes most sense to you. Okay, so on this first one, I wrote this out 4 times. It's 3s to the 4th power, so 3s times 3s times 3s times 3s. All right, I used my product rule. 3 times 3 times 3 times 3 is 81. All right, and then I had the s to the 4th. I had 4 of those s's. Now we're over 3s to the 4th. Well, look what happens. What is s to the anything divided by itself is just 1. So s to the 4th over s to the 4th is just 1. And then I'm left with 81 divided by 3, which is just 27. All right, another further breakdown of this is, okay, I just kind of did my power to a power rule. So this is 3 to the 4th power, s to the 4th power. So that's 3 to the 4th power is 81. S to the 4th power. All right, and then I broke this down into expanded form. So 81 s times blah, 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 over 3. Now, boom, 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 boom. Those all cancel each other out or simplify to a 1, and we're left with 81 divided by 3, which again is just 27. If you got 27, high five yourself. These are tough problems, a lot to wrap your head around. All right, let's look real quick next door at number 8. All right, this was your final answer, a b to the 7th power. All right, now you got to be careful here. So pay attention. I distributed the 7 here. There is a negative 1 here and a negative 1 right here too. So you have to make sure that you distribute it to him too, because if that was an 8, negative 1 to the 8th power would end up being a positive value. All right, so whenever a negative number is raised to a negative power, it's going to remain negative because it's being multiplied an odd number of amount of times. Okay, versus if a negative number is raised to a positive power, an even power, this will become a positive 1. All right, and you can always confirm that in your calculator. So I kind of distributed my power to everybody. I still had this negative 1, a to the 7th, b to the 7th over negative 1, a to the 6th power. All right, so using my rule, or I went ahead and I expanded form down here, but you would want to just subtract these to the top, and negative divided by negative is a positive. All right, so that's where I ended up with my a to the first power here. And then b to the 7th, he didn't really change. All right, and then again down here in expanded form, a negative divided by a negative becomes a positive. He gone, he gone, he gone, he gone, he gone, and he's gone, but I still have this one left over, a, and then b to the 7th power. So a times b to the 7th power. And I think that is it for our notes. So you can grab that practice. Oh, no, we're not done. All right, let's look at these real quick too. So dividing with these things, kind of with some polynomial terms here. Again, like things play together. So we could break this apart into like 9y over 3 plus 12 over 3. So essentially what we're doing is we're just simplifying these fractions. All right, and so 9 divided by 3 is 3y, and 12 divided by 3 is a positive 4. All right, so again, you can see that here, 9 divided by 3 is 3y plus 12 divided by 4, or 12 divided by 3, which is 4, okay? So we get that. All right, and then we have this one again. Why don't you try this one, pause your note video, and then you can resume. All right, and for this one, you should have got 4a plus 5b. 16 divided by 4 is 4. And 20 divided by 4 is 5, so we're left with 4a and 5b. All right, yep, these just keep getting cuter and cuter. All right, so let's talk through this first one. Again, remember, only like things are going to play together. So these are kind of just like regular polynomials. Understand, like here we're just adding and subtracting. We're not actually multiplying anything, but we are dividing, so we can handle a little bit of business here. So I'm going to deal with my numbers first. So 27 divided by, again, and if it helps you to break it down like this, you are more than welcome to do this. Minus 18r squared over negative 9r minus 36r over negative 9r. You can break down that fraction into 3 different parts. That helps you to see it better. So 27 divided by negative 9 is negative 3, and then we apply our quotient rule. All right, I'm exponent heavy on the top, so this r to the first power, I would take it and subtract it up here to get r to the second power. Okay, negative 18 divided by negative 9 is positive 2, and again, I'm top heavy, subtract him from the top, and I would get r to the first power. Negative 36 divided by negative 9 is positive 4, and then my r's are going to cancel out. So officially our answer here would be negative 3r squared plus 2r plus 4. It's not necessary to write r to the first power. That is just assumed. All right, pause the video. Why don't you guys try out number 4? All right, and I believe this is the answer you should have got. All right, so again, you see I broke it down. It just helps me to see those things a little bit better. It helps to see my fractions a little bit clearer. So 12 divided by negative 2 is negative 6. Again, I'm top heavy, so I would subtract those up there. And then q divided by q is just 1, so he disappears. All right, negative 18 divided by negative 2 is positive 9. Again, I'm top heavy, subtract those 2 from the top, we get p to the first power. And same thing here, this is q to the first power, subtract him up to the top, I get q to the first power. And then 18 divided by negative 2 is negative 9. P to the second over p to the second is just 1. And then q to the third over q to the first, subtract him up to the top, we get q to the second. Now, just a fun fact side note, we'll learn about this, I think, later, but p to the second over p to the second. Well, if you applied your quotient rule, I would subtract this up here, right? So I'd end up with p to the 0 power. Well, fun fact, in case we haven't got to it already, anything to the 0 power is just 1, which makes sense, right? Because we have p times p over p times p. Well, that cancels, and we're just left with 1. All right, so that's the 0 rule. Let's see if we have anything else here. And there we go. All right, so again, you're with the sub today. I know this stuff is hard. I need you guys to be working together, helping each other out. Break this stuff down into expanded form if you get hung up. Check the partial answer key that's posted on the board, and then turn in your assignment, or either that or you'll turn it at the beginning of class on Tuesday. So I will be back next week. I hope y'all have a great, fun-filled weekend. I love you guys, and again, thanks for being awesome for our sub.